So in lesson 43 concept, we will learn how to name line segments and how to name and make triangles. And so a line segment has two endpoints, one here and one here. And line segments can go in different directions. It can be horizontal, vertical, or oblique this direction. So the other cool thing with line segments is we name them with capital letters. So we could name this one A, B. Maybe we name this one C, D. Maybe this one E, F. And maybe this one G, H. So if I wanted to talk about one of them, I would say line segment A, B. And I write both capital letters next to each other and I put a line above them. That indicates it is a line segment. What if I want to talk about this one? I might name it CD with a line over it, or EF. You know I'm talking about this one. Or GH, and you know I'm talking about that line segment. So the next thing I want to tell you about is the fact that we can measure line segments. And we do this all the time when we measure the name line or the date line on your math papers. So what if I had a line segment like that and I name it DF? And I say DF, line segment DF is 10 inches long. It's not, but we're just pretending right at this point. And if I say DE, and I'm going to name this one E, is 7 inches long. Can you figure out how many inches line segment EF would be? So if the whole thing is 10 inches and this segment is 7 inches, how many must this segment be? If this is 7 and we want to get to 10, how many more would we need here? 3 is correct. 3 inches. Okay, or we could write it IN period, or we can write out the word inches. Okay, so you need to know how to do those. Let's try another one. Let's do it on the back here. Let's pretend we have a line segment D, E, F. And we'll put a dot right there. That's a point, and it indicates there is a line segment from D to F, D to E, and E to F. So D to F, D to E, and E to F. And let's pretend D to F is 8 centimeters long. And E to F, that means the whole thing, right, is 8 centimeters. And just E to F, 2 centimeters. How many centimeters must D to E be? Remember, the whole thing is 8 and this part's 2. So what would this have to be in order to make this equal 8? 6. That's right. This would have to be 6 centimeters plus 2 centimeters equals 8 centimeters. Okay, so you got a paper from me that has some triangles on it. I want you to turn it over on the back where the blank side is and see if you can draw a 12 centimeter line segment and label the endpoints A and C. And I'll be right back. Okay, so you should have On the back of your triangle paper, you should have drawn a 12 centimeter line segment and labeled the endpoints A and C. So I don't have my exact ruler here right now, so wait, here it is. Blends in. Okay, so we want centimeters, so that's the little side. Well, let me erase the side. You can see it better. Okay. Let's hold that there. We want 12 centimeters. I gotta lay it down so I can do it right now. Put my point there, my point at 12, and draw a line in between. Okay. Then we labeled it A and C. So this is line segment AC. Now I want you to put a point 2 centimeters from A and label it B. So put your 0 centimeters at A. And label that point B. Okay, so this is what you should have. Now, write the names of the 3 line segments. So we have AC, we have AB, and we have BC, right? AC, AB, and BC. And we need to measure them. So we know we drew AC, we knew that was 12 centimeters. That's what we initially drew. And we also knew that AB was 2 centimeters because I told you to start at A and go 2 centimeters over and write B. And then that leaves BC. Well, we can measure it, or we can figure out that 12 minus 2 is 10 centimeters, right? This was 2, 10, and the whole thing was 12 centimeters. Oops, there's not a dot there. Okay. All right, now I want you to flip your paper back over to the triangle side. And there, before we do any of those, I just want to give you a little heads up here what we're kind of doing. I'm just going to give you an example triangle, X, Y, Z. And triangles have segments too. They have 3 segments, right? Here, here, and here. And we would name this XY segment. We would name YZ a segment. And XZ is a segment. All right, so that's the way we would label the segments of that. Now let's look at the triangles that are actually on your paper. And we have, the first one is ABC. So, you want a triangle like this, ABC. And the line segments, I think they have like 3 lines over here. I want you to write AB with a line above it, BC with a line above it, and AC with a line above it. Okay, and then there's, I want you to measure these, each of these sides in centimeters. And if you do, you should get 5 centimeters for every side. And there's a special name for triangles that have every side exactly the same. They're all equal, so we call these equilateral triangles. Okay? Now there's another special triangle. Let's measure triangle DEF. Okay? So line segment DE, line segment EF, and line segment DF. So you had to write those on those lines off to the side, right? And it kind of looks something like that, right? So if you measure in centimeters, you can pause me and do it and come back. Right, you should have gotten 6 centimeters, 6 centimeters and 4 centimeters. And that is when we have two sides that are equal and one's different. We call that a I'm sorry. We do not call that scaling. We call that isosceles. Sorry. Isosceles. And the way you can remember isosceles is because two are the same and one is different, and I just kind of focus in on this SOS, right? Two S's and an O in the middle. I don't know why that helps me remember. This is the isosceles triangle, when two sides are the same and one is different. Okay, and the last kind I want to tell you about kind of looks a little bit like this, and there's 3 segments as well. Of course, it's a triangle, so there's 3 line segments. We have GH, HI, and GI. So go ahead and measure those line segments. Come back. You can pause me. Okay, did you get 6 centimeters, 10 centimeters, and 8 centimeters? What do you notice about all of those? Yeah, there's none that are the same. They're all 3 are different lengths. So, of course, there is a special name for that, and I kind of gave it away when I made my last one. Scalene. A scalene triangle, all 3 are different lengths, okay? And one more special kind of triangle, a right triangle. When you see a box in the corner of a triangle like this, that's called a right triangle. That means it's exactly 90 degrees. It's kind of like the corner of your paper, right? If you look up there, there's a right triangle there, there, and there. Right triangles are what we call 90 degrees, like a perfect corner, okay? So there's a little bonus there. Okay, so now what I would like you to do, I believe I may have given you a practice sheet, and it has the names of all the different kinds of triangles. And then the back of it is to see if you can figure out which ones they are. So like if it looks like this and has equal sign, equal sign, equal sign, that would be an equilateral triangle because all 3 are the same length. If you see this, it looks like 2 equal signs on just 2 sides, you would write isosceles. And then if you saw something like this, where there's nothing equal, there is no equal signs on there, that would be the scalene or scalene triangle. Now you will see some that have that little right angle mark. You can write right angle if you want to, but you don't have to. I'm most concerned if you understand these. Equal, all 3 equal. Isosceles, 2 sides the same. Scalene, none are the same. Scaling kind of reminds me of a scale. And then if you get on a scale, every time it could be a different weight on that scale. So nobody's is exactly the same, right? So I don't know. That helps me remember. Okay. And that is it for our new concept lesson. Bye-bye.